This will come out to be the gradient of divergence of E, gradient of the divergence of E minus Laplacian of E means del square E, and this is equal to minus curly by curly T comes first, and then del cross B. And then this side I can write del cross B value I can write from here, and it will come out to be minus curly by curly T mu naught epsilon naught and mu naught epsilon naught curly E over curly T, like this. Now look back here, divergence of E from this equation. Here, divergence of E is equal to 0, so this equation goes to 0, right? And we are getting minus del square E equals minus mu naught epsilon naught and curly square E over curly T squared. The minus and minus signs are cancelling. So we got that del square E is equal to mu naught epsilon naught del square E equals mu naught epsilon naught curly square E over curly T square. Now we want to check the dimensions of this equation. So what are the dimensions of this? Del square, we know it is curly square by curly x square plus curly square by curly y square and so on. So I'm writing one dimension. And this I can write as curly square E over curly x square. And then this is mu naught epsilon naught, and this is curly square E over curly T square. Now this is just double change in this one. So it means it is just the electric field, change in electric field. Here it is also a change in electric field. Yes. So dimensionally these two are the same, and they are gone. If I look at the dimensions of this one, they are distance dimension. Change in distance or distance square. So it means that this is 1 over x square dimension wise, and this is mu naught epsilon naught, and then this is 1 over time square dimension wise. And if I write it like this, then this one I move here and this one I move out. So it will be mu naught 1 over mu naught epsilon naught is equal to x squared over t squared. Then what is x squared over t squared? It is x over t whole square. X over t is speed. And this is speed squared. And from here I can write that V is equal to 1 over mu naught epsilon naught, like this. We know mu naught is the permeability of free space and epsilon naught is the permittivity of free space. So this thing, when calculated, then it's surprisingly came out to be exactly the speed of light. And this wave equation are the cost of decoupling them, like we utilize the whole Maxwell equations in this one. Similarly, if I take the curl of this, then the identity will be applied on this, and then it will be curl of E, and for curl of E, I will put the Faraday's equation, and again I will get curly square B over curly x square mu naught epsilon naught curly square d over curly t square, the same equation. So it was like curly square E over curly x square or del square E. And let me write this thing in the del square form, like in 3 dimension. Let me write this one. So this is del square E is equal to 1 over V square and curly square E over curly T square. 1 over V square. Because here is mu naught epsilon naught reciprocating square. This is the cost of decoupling, means they are first order differential equation. When we just decouple them, we got a second order differential equation. So this is the cost of decoupling. But here something very surprising was observed. What does it mean actually? It means that when you consider an electromagnetic field, then the ripples of electric and magnetic field are floating. And those ripples are changing into each other at the speed of light. So when we say that electric and magnetic components are vectors, they are traveling with the speed of light. Or in other words, Maxwell said that we can also say that light is itself electric and magnetic components. So like it is itself light which travels at the speed of light. And that was a remarkable job done by Maxwell. And for this reason he got Nobel Prize on this thing. But there was again an issue of reference, frame, or the relative motion. Means Maxwell was, of course, worried about this thing. That if light is moving, then it is moving with respect to what? Means light is moving, its speed is this much. It was theoretically derived, experimentally measured, both were the same, but yet the question was there that people didn't know that there will be some speed which will be irrespective of any reference, irrespective of any frame. It is something which is beyond this thing. It's a huge speed and it is beyond this thing. And Maxwell just proposed a theory, and theory of ether. It is written like this or this, ether. And Maxwell said that there is a hypothetical medium which we call ether, and this light is traveling with respect to that ether. And then there were the two genius minds, Michelson and Morley. Michelson and Morley, they did some experiment with the help of their interferometer. And the interferometer they developed, now in almost all scientific devices we are having those interferometer incorporated. So Michelson and Morley, probably in 1930s, they measured the speed of light in different directions, and they said that there is no ether at all. There is no such medium like the one proposed by Maxwell, a hypothetical medium either, because at that time there was no clue of any motion which is with respect to nothing. And he said that it is ether, and they determined that there is no ether at all. Because if there would be ether, then the light would have different speeds in different directions, and they came to know that there is no ether, and the people were stuck or confused, and then the genius mind of Albert Einstein came in. And Albert Einstein said that when you are behind a certain frame, why you are behind a certain reference, are the equations imposing this condition that there should be a reference, or are the equations imposing a condition that this motion is to be relative? So the equations are not putting any restriction. So he said that don't search for the reference then. It is something which is the equations are giving you directly, and the equations don't need this thing to be relative, then why you are in search of such a reference? So he said the speed of light in vacuum is always equal to c, and it is regardless of the motion of either source or observer. And this thing was, you can say the mystery was resolved, because if I consider the relative motion, then if for example this thing, an observer now moving, let's say an observer is moving, this is an observer who is moving at 10 meter per second. And now this observer is moving on a moving train, and the train itself is moving, let's say, 800 meters per second. So, what will be the net velocity of this person? The net velocity will be 10 plus 100, and it will be 110. This is Galilean motion algebra, this is Newton motion algebra. But now consider that this man who is running, let's say, at 10 meter per second, and he switch on a torch. Okay? He switch on a torch. So is the speed now 3 into 10 power 8 meter per second plus 10 meter per second? Or if he is moving in a plane, I see, and let's say the plane is moving, let's say 8,000 meter per second, and he do the same thing. So is this thing, this speed is being aided with 1,000 meter per second? Both the Galilean and the Newtonian algebra is saying that yes, it will be this plus this. If he is moving in a space shuttle, okay, moving in a space shuttle and torch up the light, like this one is approximately, I say, let's say 0.2 c, and he switch on the torch, then the torch, the light is aiming speed c. So is the speed equal to 1.2 c? And according to the earlier algebra or earlier consideration of motion, all these are right. But according to the special theory of relativity, the answer of all them is no. The speed of light in this case will be c, in this case will be c, and in this case will be c. And the same is true if, for example, he is an observer or a source. He is a source. This source is moving. Now, if the observer is here and the source is moving opposite to him, or he is moving toward the source. Both the situations, the Newtonian or the Galilean algebra will say that yes, both the motions will be aided, but not this kind of motion. The speed of light will not accept those motions. It is regardless of the motion of observer or source. So in all the cases, they will just, our predictor will just measure the speed of light is equal to c. Here is one thing uh, which came after Einstein, and that was that electric field in one frame may be seen as magnetic field in the other frame. Like a frame in motion. Let's say I consider an example that I'm traveling in a car and I'm having a briefcase full of charges, and it is on the seat with me inside my car. What I'm observing that there is an electric field in the car. But an observer who is outside and he is at rest and I am moving with respect to him. So at the same time, this field which seems as magnetic field.